In the first part, we just wrote our the wage setting and price setting equation in terms of the real wage, and in the next two parts, we just plotted them once with unemployment rate on the horizontal axis and then with the level of employment on the horizontal axis. Now, what to do about it? We want to find equilibrium unemployment rate, wage, and so let's start with the equilibrium unemployment rate. So for equilibrium unemployment rate, which is UN, for the equilibrium unemployment rate UN, right? So we know KUN occurs at intersection of WS and PS, and to be more specific, this is the equilibrium of unemployment when P is equal to P, and since in this question we're already making the assumption P is equal to PE, because the wage setting equation, if you look at, is written as a function of P rather than PE. So the question is already making the assumption that P is equal to PE, and we know under the assumption P is equal to PE, the equilibrium unemployment rate is the natural rate of unemployment, right? So the equilibrium unemployment rate is UN over here because we already have the assumption P is equal to PE in the question. So now WS in terms of real wage. If we go back, we wrote the WS in terms of the real wage as, if we look at it, we wrote it as W by P is equal to C1 minus U. So this is W by P equal to Z1 minus U. And then we have PS in terms of real wage. So if we go back in part A, we wrote this as W by P is 1 by 1 plus. So we know the national rate of unemployment occurs at the intersection of WS and PS, right? Because equilibrium occurs where WS is equal to PS. So setting the two equal. Z1 minus U is 1 by 1 plus N. So from here we can solve for U. So let's take the Z1 minus. And then from here we can write UN is equal to 1 minus 1 by Z1 plus N. So this is the equilibrium unemployment rate. Essentially, if we go back to the figure we plotted in part A, if we go back to the figure we plotted in part A, so this is essentially UN. So UN is 1 minus 1 by Z1 plus at the intersection of WS and X. So now we want to look at for equilibrium real wage. Now, if we go back to our figure, so we know. So if we go back to the figure that we plotted, we know this is the equilibrium with WS and PS. WS is equal to PS. This is the national wage of unemployment rate. So now the equilibrium real wage you can see simply given by the PS, right? This is the equilibrium point. This is the equilibrium level of unemployment, and this is the equilibrium real wage simply given by the horizontal PS curve. Real wage, equilibrium real wage in this model is simply given, again the key is that because the PS curve is horizontal, is simply given by the horizontal. Again the key is that it's horizontal PS curve. So equilibrium real wage, so we have, so we have W by PS 1 by 1 plus, right? Because see, we saw over here, okay, this is on the vertical axis W by P, here we have U. So this is our PS and this is our WS, right? In general. So equilibrium occurs where WS is equal to PS, and this is the equilibrium real wage simply given by the horizontal PS curve, which is 1 by 1 plus N. Right, so equilibrium real wage you don't really have to find, simply given by the horizontal PS curve. Note, we could have found equilibrium real wage by plugging UN in WS equation, would get same answer. We could have done that. Look, see, if I go back the proper figure we do in part A. So we can see over here, this is the equilibrium where u is equal to un. And we said equilibrium radius is simply given by the PS curve. But alternatively, what we could have done is we could have plugged this value of un into a WS equation, which would have given us the exact same value for the equilibrium railway. Since see this point occurs at the intersection. So this means that point satisfies both of the equations. So once you have the value of un, we could plug this into the WS equation in order to find this equilibrium value of the railway, because in this case we're essentially simultaneously solving two equations. So once simultaneously solving the WS and PS equation, we have the values. We could plug it into one of these equations, which could be the WS equation, and get the value of the other variable that we're trying to solve for, which is the rate wage. Because essentially what you're doing is we're simultaneously solving for two variables, right? One is W by P and one is U, right? We're simultaneously solving for the real wage and the unemployment. And so once we have the value of a U from the UN from the WS, once you have the value of UN, by simultaneously solving these two equations, by setting them equal to each other, we can plug in the value of U in one of these, which could be the WS equation, and get the value of the other variable, which is the real wage. Because what we're essentially doing over here is we are simultaneously solving two equations, right? Like here we are simultaneously solving these two equations. We have two unknowns over here, right? We have two unknowns over here, W by P and U. So once we simultaneously solve this and get the value of one of these, we can plug the value into WS equation and solve for W by P as well, although we don't have to do that, because in this case, the PS curve is horizontal, so the equilibrium wage, real wage, is simply given by the PS curve. But yes, an alternative way is that you can plug in the value of UN into the WS equation to get the equilibrium real wage, because again, it's the equilibrium which satisfies. If we had done that, then in that case, if I plug in UN into the WS equation, so this is Z1 minus U, so I plug in the value of UN, which we know is 1 minus 1 by Z1 plus N. Right, so this is the value of UN, because remember W by P was Z1 minus U, so I just plugged in UN here, and you can see that once I simplify this turns out to be the exact same equilibrium rate, so this turns out to be 1 by 1 plus N. So when you want to find equilibrium rate, it's simply given with a horizontal PS curve, but yes, you can still find it by plugging in values here in the WS equation, although that's not necessary. So now for equilibrium output. So I want to find equilibrium output. This is the natural level of output. In this case, production function is given by. So whenever you want to find your equilibrium output, or your interest in output, you have to go back to the production function, right? So production function. So whenever you want to find the equilibrium value of output, you have to go back and see what the production function is given to you. Let's see what the production function is given to you. So if we go back up in the question, we can see the production function is given to us as y is equal to n, right? So whenever you're finding the equilibrium output, you need to see what your production function is. So in this case, production function is given to us as yn, because production function is relevant for finding output. So this is given to us in the question. So this is given in question. Now we already found, now the idea is that we already found un. We just found the equilibrium value of unemployment rate. So if we rewrite y in terms of u, right now y is written in terms of n, obviously. Output, based on the production function, output would obviously be written in terms of level of employment. So what if we rewrite y in terms of u rather than n? We can plug in value of un to get value of y. We know based on our production function, output is written in terms of level of employment, but instead of n, if I write it in terms of the unemployment rate, then I can plug in the value of un to get the value of y. For this, we want, sorry, for this, we want a relation between n and u, and we know n and u are always connected because n is the level of employment, u is the unemployment rate, so they'll be connected to the labor force, right? Because labor force includes both employed and unemployed. We already found this in part C. We already found this in part C. So in part C, we already found a relationship between them as this, right? So this is something when we were plotting our, if we go back, so when we were plotting our weight setting and price setting against level of employment and unemployment rate, we derive this relationship between them. Where we said that since, so we have already derived this, where we said that since the, let's just zoom this in a bit, where we said that since the labor force includes both employed and unemployed, from here we can write N as L minus U, but this gives us a relation between the level of employment and the level of unemployment, capital U, where capital U is the level of unemployment. But we're interested in a relationship between capital N and small u. Small u is unemployment rate, because what we found using the WSBS model is the equilibrium rate of unemployment, not the equilibrium level of unemployment. So what we found is the value is equilibrium value small u, right? So we wanted to write capital N. So we want capital N written in terms of small u, right? So here we can use the fact that unemployment rate as the level of unemployment divided by the labor force. So this means the level of unemployment can be written as unemployment rate into labor force. And from here you can write N is L minus UL and then factor out N and you get this relationship between N and U, and that makes intuitive sense. Because of U is unemployment rate, 1 minus U is the employment rate. If you multiply by the labor force, you get the level of employment. So we already derived this in detail in part C. Right, so now, again, the idea over here was that through the labor force, you can get a relationship between N and capital U, which is the level of unemployment. But in the WSPS model, the analysis that we're doing is with small u, which is unemployment rates. We have to rewrite capital N in terms of small u rather than capital U, right? Right, so moving forward, so we already have this relationship which we found in part C, the what we have over here, N is 1 minus. So if I use this, so rewriting y in terms of, so I have y, the production function will obviously be given in terms of the level of employment, but using the relationship between N and U, I can write it in terms of small. So y is 1 minus UL, because what we've done is we have just replaced this N with over here, right? So we just done that. So now we know in equilibrium, U is equal to equilibrium U is UN is 1 minus 1 by Z1 plus M. We just found this equilibrium value. So in equilibrium, Y is given as, so just plug in the, so we know Y is 1 minus UL. So if in equilibrium U is UN, then Y is going to be YN is 1 minus UN times it. So then this is just going to be 1 minus, and then this is UN, 1 minus 1 by Z1 plus N. Right, and then this is what this is human, right? So if you just simplify this turns out to be LC1, right? Because we know we know y is 1 minus UL. So if I plug in the equilibrium values U is equal to U and A, we get the equilibrium value by pi. So this is how we can find equilibrium unemployment rate, equilibrium real wage, and equilibrium level of output.